All right, today we are treating Mass 201. Mass 201, and we will be looking at evaluation of limit. Evaluation of limit. And so there are several ways. Limits can be evaluated. There are several ways limits can be evaluated, right? One of the ways we have is, number one, we have by direct substitution. Another way we have is testing along a straight line. Another way limit can be evaluated is path by approach method. Evaluation of limit, path by approach. Then we have testing along a curve. So these are ways, although we have several ways, these are the basic ways you can evaluate a limit. All right, so let us look at a sample together. So we're asked to evaluate the limit as x, y approaches 1, minus 4. You see that? Of y plus 4 over x squared y plus xy plus 4x squared plus 4x. Did you see that? So how do we approach this question? And so we say, let's directly substitute the values of x and y. And so what we'll be having here is minus 4. So whenever I see y, I place it as minus 4 because this represents x and this represents y. All right, so we have minus 4 plus 4. All should divide 1 to the power of 2 minus 4 plus 1 minus 4 plus 4, 1 squared plus 4 into bracket 1. Did you see that? And so, having directly substituted this, we have 0 over 0 because this gives 0, this gives 0, right? Now that we have 0 over 0, we know that in mathematics it is wrong for you to have 0 over 0, because if you punch this into the calculator, you're gonna have error, maths error. Your calculator, remember, is an engine, and so when you punch this into the calculator, you have maths error. And so what do we do to solve this problem? Okay, so we can say, mind you, another approach you can use when solving, aside the 4 I listed, is by factorization. You can solve evaluation of limits by factorization. All right, so let us factorize. So we have the limit, all right, as x, y approaches 1 comma minus 4 of y plus 4 over. Now, if you factorize with respect to x here, if you factorize with respect to x here, x and y here, mind you, you're going to have xy into the bracket of x plus 1. Why do you have that? Because when you multiply xy multiplied by x, you're going to be having x squared y, right? And when you have 1 multiplied by xy, you're going to be having xy. Then you say plus, what is common to both sides? 4x is common to both sides, right? Because you can divide this by 4x and have x. You can divide it by 4x and have 1. So we have 4x into the bracket of x plus 1, right? Now, let's take into consideration, it means the limit as x comma y approaches 1 comma 4 comma minus 4, 1 comma minus 4 of y plus 4 over y plus 4 over x plus 1, right? Since x plus 1 is common to both sides, right? Into bracket of xy plus 4x, right? So we can either pick one of them, right? And so we now have it that you can say the limits as x comma y approaches 1 comma minus 4 of y plus 4 over x plus 1 into the bracket. Now, what is common to both sides here is x. Did you see that? X is common to both sides, so we have x into the bracket of y plus 4. Did you see that? X into the bracket of y plus 4. And so we can then say that we have y plus 4 divided by x plus 1, x into bracket y plus 4, and so you can cancel out and say 1 over x plus 1 into bracket of x. Don't forget the limit as x comma y approaches 1 comma minus 4. Don't forget. And so from there you can now insert the points. Why do we have to go through these steps? So we say, note that whenever direct substitution, whenever you try a direct substitution method, whenever a direct substitution gives you 0 over 0, it says try other method. And this method includes, you can try by factorization. You can try part by approach. You can try along a straight line. You know, you can try along a curve. Yeah, you can try other methods, right? So we said whenever a direct substitution gives 0 over 0, which is maths error in calculator, then you should try another method. Is that correct? All right. Now that we have said so, let's get back to the business. And so we say that the limit as x comma y approaches 1 to minus 4 of 1 over x plus 1 into the brackets of x. And so from here, we now insert the point. Insert the what? The point. So we only have x here, so we're going to place x as 1. So we say 1 over 1 plus 1 into bracket 1, which is 1 over 2, right? It means that the limit as x approaches, as x comma y approaches 1 comma minus 4 of the function y plus 4 x plus 1 x, right? X plus 1 x of y plus 4, the answer is 1 over 2. So the limit to this question is 1 over 2. And why did we do that? We had to pass through this procedure because when you do a direct substitution and you have 0 over 0, you try other approach. Let's look at another question. Another very important question. Another very important question. It says, evaluate the limit. Lim as x comma y approaches 0 comma 0 of the function x plus y over 2x minus y. X plus y over 2x minus y. So what do we do here? Again, I said step one, directly substitute the values, right? When you directly substitute the values, what you're going to be having is 0 plus 0 over 2 into bracket 0 minus 0, which is 0 over 0. Like I said earlier, I said this is maths error. In fact, we call this indeterminate, or we call it undefined. We call it indeterminate or we call it undefined. So this is an error in mathematics when you have 0 over 0. And so we have to try another method. And so the method I'm going to try, because I cannot factorize here. Nothing is common to this and nothing is common to this. Nothing is common to this and these are two different variables, right? I can't factorize here. So it is best for me to try another method. And the method we'll be trying is the path by approach method. So step 2, we apply the path by approach method. Applying the path by approach method. And what does the path by approach method say? What does the path by approach method say? It says, when you want to test a function, let one of the variables go in first before the next variable. So we are simply saying that the limit as x approaches 0 of the function of the limit as y approaches 0 of x plus y over 2x minus y. So x is going in first, so we are testing for x first. So which means limit as x approaches 0 of x, did you see that? So we are testing for y, rather we are testing for y first. Testing for y first. That's why I say path by approach. This person goes in first before this person. So we said x plus 0 over 2x minus 0. So what do we have? We have the limit as x approaches 0 of the function x over 2x. Did you see that? X over 2x. And so we said this equates to the limit as x approaches 0 of 1 over 2, because x cancels x here, 1, so we have 1 over 2 here. right? So the limit as x approaches 0 of 1 over 2 is still 1 over 2. Why? Because there's no place for you to put x here. There's no place to contain x, so it's still going to be 1 over 2. Now that we have 1 over 2, let us test for, here we test for y. So let's test for x. The limit as, what am I going to write here? Y approaches 0 of the function. What will be inside the bracket? If at this junction you had limit as y approaches 0, here will be the limit as x approaches 0 of the same function, x plus y over 2x minus y. Did you see that? And so we said is equal to the limit, of y approaches 0, of, now if you put in 0 here, this should be 0 plus y over 0 minus y. Is that correct? Yeah, because anywhere I see x, I'm putting it as 0. Remember, it's x that's in the bracket. X, the limit of x approaching 0. Yeah, so whenever I see x, I place it as 0. Here, it's y, that's the limit of y approaching 0. So whenever I see y, I put it as 0. That is why you're having x plus y, x plus 0, 2x minus y, 2x minus 0. Right? So the same thing goes for this. So we have the limit as y approaches 0 of the function. You're gonna have minus 1, because this is y over minus y, which is minus 1. And so the limit as x approaches 0, which is equal to 1 over 2, 1 over 2, is not the same thing. It's not the same thing as the limit as y approaches 0, which is equal to minus 1. So whenever you test by part by approach, and the answers you are getting are not the same, this is 1 over 2, this is minus 1, they are not the same. The fact that they are not the same tells us that the function or the limit does not exist. So our final answer is the limit does not exist. The limit does not exist. All right, the limit does not exist. Why? Because when you tested for limit as x approaches 0, it gave you 1 over 2. When you tested for the limit as y approaches 0, it gave you minus 1. So the limit does not exist. But if the answers were to be the same, if we have 1 over 2 here and you have 1 over 2 there, then the limit is continuous at 1 over 2, or the limit exists. You can say the limit exists and it is continuous at 1 over 2. All right, let us look at a more intricate example. Let's look at it together. More intricate example. All right. Okay, we say we want to evaluate the limit. Evaluate the limit as x comma y approaches 0 comma 0. So 2x squared y over x squared plus y squared. Right? So what did I say? I said at this point, the first step you're going to do when testing for limit is to do a direct substitution. A direct substitution. And so when you do a direct substitution, what you'll be having is 2 into bracket 0 over 0 plus 0. What is 0 over 0? which is undefined, which is indeterminate. Indeterminate. This is an error. Indeterminate. This is an error in mathematics. We don't want to do this. We don't like to see this. This is an error. And so what do? We try other steps. So this time around, instead of me to try the path by approach, let me use another unique step. Let me try along a straight line. So we say test along a straight line. Test along a straight line. Test along a straight line. Step 2, test along a straight line. And so when you test along a straight line, you have when y is equal to mx. So let us test along a straight line. This is the function, remember? This is the function. So anywhere I see y, I'm going to substitute it as mx. Alright? Whenever I see y, I'm going to substitute that as mx. And so we are having lim as x approaches 0 of the function. So we have 2x squared. So I'm supposed to see y here, so I'm going to replace it as mx. So mx over x squared plus mx, but all squared. Did you see that? Did you see that? What I just simply did is to replace y to be mx. To replace y to be mx. And so we have that the limit as x approaches 0, of the function, 2mx cubed. Why do we have to the power of 3 of x? Because x squared multiplied by x will give you x to the power of 3 over x squared plus m squared x squared. Did you see that? And so when you have it like this, what do we do next? Can we factorize this? Okay, let's see that. Can we factorize this? Let's look at it together. So this will be lim as x approaches 0 of the function x squared into brackets 2mx. Yeah, I want to factorize so I can cancel out the denominator. So x squared into bracket 2mx, I'm factorizing this, bringing out x squared from here. So if I bring out x squared from here, what will be left is x. So this is the x squared here, into the bracket of 2mx, over x squared into the bracket of 1 plus m squared. Did you see that? You can also factorize here. What is common to both sides? X squared. Right? So what we have now is this. And so we can cancel out and say that what we have is the limit as x approaches 0 of 2mx over 1 plus m squared. Did you see that? Over 1 plus m squared. So let's substitute x for the value of 0. What you have is 2m into bracket 0 over 1 plus m squared, which is 0 over 1 plus m squared. 0 over 1 plus m squared, which is equal to 0. So I'm not satisfied with this answer. Let me test it along a curve. I'm not satisfied with this answer. So let me use another method by testing along a curve. And when you test along a curve, it is y equals to x squared. So you see that when we test along a curve, it is y equals to x squared. But when we test along a straight line, it is y equals mx. So let's test along a curve. Let us test it along a curve. Let us test it along a curve. Let us test it along a curve. Y equals x squared along a curve. So what we have is the limit as x approaches 0 of the function 2x squared into bracket x squared over x squared plus x squared squared. What did I do? What did I just do? I replaced every y with what? X squared. You remember that the question itself is 2x squared y over x squared plus y squared. And since y is x squared, so I'm replacing y to be x squared. So we have this, right? This replacement happened in the original question. The original question says 2x squared y 2x squared y over x squared plus y squared. And so because y already is x squared, we are testing along a curve. We are testing along a curve. And so when you test along a curve, what you have is y is equal to x squared. And so I replace y to be x squared. And so when you have that, this is what is the replicant of what you have. This is your result. And so let us continue. What we have now is the limit as x approaches 0 of the function 2x to the power of 4. X squared times x squared is x to the power of 4 over x squared plus, this is also x to the power of 4, x to the power of 4. Is that clear? Alright, can we factorize here? Yes. This is the limit as x approaches 0 of the function x to the power of 2 into brackets 2x squared over x to the power of 2 into bracket 1 plus x to the power of 2. Right? Is that correct? And so this cancels out this. Now we have, can I clean this part? Yes, I can. Okay. Now we have the limit as x approaches 0 of the function 2x squared over 1 plus x squared. This is the limit as x approaches 0 of the function. And so what will be our answer? Our answer to this is to place x as 0. So we have 2 to bracket 0 whole squared, 1 plus 0 whole squared. We have 0 over 1, 0 over 1. And 0 over 1 is equal to 0. So, have you been able to discover that when we tested, since we tested along a straight line, where y was equal to mx, and we got 0. And again, we tested along a curve, where y is equal to x squared, and we got 0. Since we're having the same answers here, 0 and 0, it means the limit exists. Let's write that out. Quickly. The limit exists. The limit exists, and it is continuous at 0. It's continuous at 0, and it's equal to 0, or you can say equal to 0. All right. So evaluation of limit. You can remember in your 100 level, what you were doing is the limit, for example, as x approaches 0 of the function 2x squared over 5, something like this. You were dealing with one variable. In your first year, you were dealing with one variable, and so the difference between what you're doing now and what you have been doing before is that at this point you are dealing with two variables, x and y, multi-variables, several variables. And so we have been able to understand what it takes to evaluate a limit. We've been able to understand what it takes to evaluate a limit. All right, so see you in our next class. It was a wonderful time having to hang around with us. We appreciate that.